Hello everyone, this is a problem from Statistical Mechanics. Here the problem says, under what circumstances the entropy of an isolated system A will remain constant or increases. For convenience, you may assume that A can be divided into subsystems B and C which are in weak contact with each other but which themselves remain in internal thermodynamic equilibrium. So here there is a isolated system A. We need to say that the entropy will remain constant or increases, and they have given like we can divide the system isolated system A can be divided into two subsystem B and C. They are in weak contact but they are in internal thermodynamic equilibrium. So here our system B and C. So let us consider T1 is the temperature of B and T2 is the temperature of C, subsystem C, and we consider T1 is greater than T2. Fine. Then if we consider if T1 is greater than T2 and they are in thermodynamic equilibrium, internal thermodynamic equilibrium, so there will be some change in energy. Fine. So let the change in energy be del Q, which is transferring from subsystem B to subsystem C. Fine. Then if it is so, then according to definition of entropy, if there is a exchange of small energy, so what is our small energies? Delta Q. Fine. Where here delta Q is greater than 0. Fine. Then we can write delta Q. So this is our formula. Actually we can relate with delta Q equal to T del S. We know this formula, so with using this formula for system B we can write delta Q, that is the change of small energy from subsystem B to C. Fine. But that change is decreasing for subsystem B. That means the change will be negative for subsystem B, and that will be equal to temperature of B is T1 and delta S, change in entropy for subsystem B. So this is for system B. Fine. Next, similarly for system C, so now the change is adding to subsystem C, therefore the change in energy will be positive for subsystem C. Temperature for subsystem C is T2 and change in entropy will be delta S C. Fine. So let us denote it by subsystem C for subsystem C. Then this can also be written as, if I want to write in terms of change in entropy for B, it can be written as delta Q divided by T1, and for this delta SC equal to plus delta Q T2. So this is our two subsystem and the whole system is A. Fine. So for the whole system we need to find the entropy. We want to say whether it is constant or increase. So we will consider the change in entropy for the whole system will be delta S. That will be given by the addition of entropy change for B and C. Then that will be equal to what? Delta S equal to delta S change in entropy in subsystem B plus change in entropy in subsystem C. So this can be written as minus delta Q T1 plus delta Q T2. Fine. Finally this can be written as delta Q T1 minus C2 divided by T1 into T2. Here this is what, this will be greater than 0. Fine. Greater than or equal to 0. Since why? Your T1 is greater than equal to T2, right? We have already considered. Fine. So here delta S will be greater than 0 if T1 is not equal to T2. Fine. So they said it will increase. So this is increasing when our delta S, or when our two system has different temperature. When the temperature of B is not equal to temperature of C, then your change in entropy or entropy increases. Fine. But when it will decrease? It will decrease when the temperature of subsystem B is equal to subsystem C. Then from this equation we can see that the difference. So the whole equation will end up to 0. So finally we can say when this temperature of B is equal to temperature of C, your delta S will be 0. That means what? Your change of entropy for whole system, for whole isolated system A is 0. That means S is constant. So these are the two conditions when it will remain constant and when it will remain increase. Thank you.